Well, welcome back to the shop, everyone. I got box parts to go in this bad boy. So I think I'm not going to show the whole ordeal, I don't think. The first thing I'm going to do is once I take the box apart, I'm going to pull this switch, or I'm going to start on this switch here, and I've got a ton of parts here from Mouser. That's for the capacitors. It's all the material safety data sheets and blah, but that's for all of this mess here. All that mess there. Got to go in there. So I don't think I'm going to bore you with that. Soldering, cutting, and all that's kind of boring, but that's my project for the afternoon. Let's see how far we can get along with it. Bring you back. Okay, this is our first project of this Handy 75 here. This is the ring here, the common ring, which goes to common. If you'll see the black wire right here, goes to this ring, goes all the way around, goes to the minus lead, common, and then all these resistors, they just solder on this ring down to their respective terminals on here. So what I'm about to do, I'm going to cut all these resistors off the ring and just replace, and just go back in, clean the connections on the switches, and then I'll just line up the resistors on each place that they go. One thing that I did do is right there, that little red mark tells me where the first resistor in line is. In this case it would be the 10 ohm 1 watt and the 10K half watt. That tells me where they start, and then I'll just go clockwise with the rest of them, and when I get them all soldered back in, then I'll solder them on the ring. So now I just got to cut all this stuff loose, cut the resistors off, desolder the ring, get all that cleaned up, and start putting the new resistors on. And I ain't going to bore you with that. I'll bring you back when I'm done. Alright, see you then. Alright, let us change of plan here. What I decided to do is take the ring off first, which is this. That's the ring. Try to save it. I want to start, and I'll just pull each resistor off at a time. That way I ain't got to worry about counting where I've started and all that other mess. So that's what I'm going to do next. But anyway, that's where I'm at so far. Bring you back on the next phase. Alright. I have done the half watt resistors. Now to do the 1 watt resistors. And that's the debris pile so far. Now I've got the half watts, the 1 watts to do. And we'll be onto the ring. Get that done. Make an ohmage check and move on. Yeah, that was fun. There's the debris pile. Here's the ring. It's done. Just got to go in and make sure everything, their spaces are good. That's it. The resistor, the 1/2 watts and the 1 watts have been changed. Now what I want to show you is, and this is what I don't like about these new components compared to the old ones. Believe it or not, this is a 1/2 watt. This is a 1 watt. Can you believe that crap? Oh man, well, that's modern equipment, but boy, I just don't like it. I should have just ordered all 2 watts and put all just 2 watts in there. But hey, it's done already. So I'm done with it. I'm going to clean it up and get my ohm meter out and check the resistances and move on. All right, we have I've completed the carbon resistor change out right here. Looks pretty decent. I'm good with it. The wire round resistors, which are these sand-ohms, as I'm going to call them, these sand-ohms, that will be the last thing I do. As far as the capacitor and rectifiers, they all tested fine. I gotta remember to keep this thing in frame. I saw it. So the last thing that we have to do, or the next to the last thing, is we need to change all these. This is the electrolytic capacitor switch. As you see, I've cleaned it up. I removed all the wiring from it. Everything's been checked. Everything's ready to, good to go, as some people like to say. So these are all the replacement capacitors. And I decided to go with the original capacitors. I want this thing to be like it was when it was new. So there I go, getting it out of frame again. I just can't. I get so caught up looking at the camera, I don't even pay attention to the viewfinder. I just point it. Anyway, I ordered the exact capacitors as close as I could get. I wanted to keep it like it was. Yes, I could have adjusted the values a little bit, but honestly, if I want a 1 ohm, a 1 microfarad capacitor right here, all I would simply do is just plug from A to B, and that would, capacitance in series halves. So that's all I would have to do. You could do this different ways to get the same values. Like here's a 0.1, a 0.5 microfarad over here. So I think it's covered. I think everything you need. Yeah, so I could have probably went in here to this one and put 1,000 microfarad in there, and maybe I should, maybe I shouldn't, but if I decide I want it later, I know how to do it. Anyway, these are the Canoe capacitors from Mouser. Let's see here. These are the 2.2s right here. Let's see. This is 6.8 microfarad. Let's see. This one here is 82 at 450. Let's see. Here's the 22, and this one's a 10. So that's 10 and 22. Let's see. This is a 39, which is basically a 40, and then a 33 at. And then this one here is a 120. This should be another 120, which it is. So all in all, there's 10 capacitors that I got to change. And I've seen another guy on YouTube. He put in just a ton of capacitors in there and he changed the switch too. Yeah, that's fine, but like I said, I'm going to leave this like it came from, like it was originally intended. I did notice that some of these values here, 80, 100, let's see, the 30, 60 right here, this one, we're all backwards. The values are actually 60, 30, 80, 40, 180, and 150, 125. The way this thing was wired, all that was, dang it, I'm getting all out of frame. The way this thing was wired, these values were backwards. I don't know if I can figure out a way to fix that or not. I don't want to change this writing on this, but oh well. Anyway, I'm going to shut you down and put the camera on charge, and I'm going to see what I can do with these capacitors. Bring you back, and I got something important. Alright, most of the work's been done. I finished the capacitors. There it is. Pull it back a little bit, you can see it a little better. I have the resistor. I don't have it mounted yet. I just got it laying in there for right now. But that's the this is the capacitor board right here. This is C1, C2, and C3. This is the 1, 2, 3, and 4. I made a list here of all the connections here. I wired. I mapped out the switch and labeled which color wire went to what capacitor, and just started and went counterclockwise. Here's my legend right here, and I wired up this circuit board accordingly. So put new wire on it. Everything's neat and good to go. Resistors are good to go. The new replacement 25 ohm element for this sand dome is in place. Like I say, though, I hadn't mounted it yet. I'll do that later, but everything's ready to go. No big deal. I've got my resolver fired up and ready to roll. So let's see. I'm going to test the A function. Should be let's try it. It should be 2 microfarad on A on that position. So let's just see. I'm going to test electrolytics. I don't know what happened. Showing 5 picofarads. Try that again. I'm showing 20.2. That's not right because it's going to have to, I got to bypass those resistors. Hang on. The way this thing works, it's fooling my, I got to connect directly to. I don't really like the way this thing is wired as far as that function goes. So let me find the ground. Come on, dude. Work with me, not against me. Let's see. A is going to be the white. So we're just going to tie right on to this resistor here. Try that again. That's showing 21.9 microfarad. Oh well. That shows 24 microfarad. That shows 32. I guess I got something wrong. Shows 20. Another 20. 34, 56, 92, 150. Let's see. Just realized I'm missing a capacitor. No, that's 250 right there. So, don't quite know on my 2.2 is measuring 21.9. I don't know. Let me figure it out. Okay, I fixed the problem. I had 2 blues backwards. So, I've got the surge protector back in, so that wasn't the problem. Back on the 2 microfarad, section A. Capacitor value, if you can read it, is 2 microfarad. I'm going to go up to 4. Let's see what happens on 4. 4 is 4.16. Good on that. Going up to 10 microfarad. Showing 11. So far so good. Now I'm on the 20. And the 20 is measuring 19. Going up to 40, and that's just probably going to be backwards. It's probably going to measure 25. Nope, measuring 40. I can't believe it. Wow, some of these are backwards. I know it is. This should be 30 or 50. Yep, 50. That's one of them that's backwards. See right here? 30, 50. That's supposed to be A. It's supposed to be B. Let me see. Oh, I see. It's not backwards. It's just how you interpret it. Yeah, when you get right here, the scale is split right here. So this would be 30 on B and 60 on A. I got it. All right. So that should be 60 then. Kind of funky, isn't it? Anyway, it's measuring 50. Close enough. This should be 80. Alright, I'm good with that. This should be 100. Yeah, it says it should be 100. Hell, I don't know. Let's go back to this one. I'm showing 50. That's 71. That's 85. It's going to be the 80. Who knows what this is? 140. That would be the 150. That should be 250. Which it is. So, okay, well, that's working. Turn it around. Let's measure the other side. Did everything right. That should be 2 microfarad. Okay, 2. That should be 6. 7.5. Close enough for government work. Should be a 10. Showing 9. Jiggy with that. Should be 25 more or less. Showing 20. 9, let's see, 25. Do that again. Showing 20. Should be 25. That's showing 20. Let me look into that. 30, 60, so what is it going to be? 30. That's, I guess, be 40. Yeah. I guess this will be 80. Yeah. 125, if everything's right. Yeah, 120. And this should be 0, I think. Yep. Alright, well, there it is. That's done. Very good, very good. I just had 2 blues. I had this blue right here and that blue right there, which goes into there. I had those 2 backwards. Big deal. There they are. I used 10 capacitors on this. I put the same values as close as I could back in here. So just use a plain old perf board. Nothing fancy on mounted. I just drilled some screws in the bottom. I used some grommets. I didn't have any spacers, so I just used some grommets to space the board. No big deal. It'll work forever. I want to tie all these back up. I'll tie them back later. I'm tired. The resistor's in place, so I guess I could check that. Let's check that real quick. Let's see, how can I do that? Let me put you down for a second. Just give me a second, ladies and germs. Gotta get the right test equipment out here. I don't know if this qualifies as the right test equipment. No. I honestly could use... Alright, I'm just going to do it cheap and dirty, okay? I'm getting tired. I'm about ready to give this up for the night. So, we'll just put that in there. Put you down one more time. I'm always putting you down like a bad dog. I hate these cheap little grapplers. Okay, now let this messing around. Let's put this in ohms. Alright, we're on the 2.5, 2.5, 5, 7.5, 10, 15, 25. That's 57, close enough. That's 75, 100, 150. Go to the 100, or time 100. So that should be 250. That should be 500, 750. That should be what, 980. That'll be 1,000. Be 1,500. That's 20. That should be 2,500. That should be 50. I'm sorry. 5,000, I guess. 7,500. 10,000. And 15,000. That's pretty close for government work. So everything works on this dude now. Hooray, hooray. We'll go back in here tomorrow, I guess, clean it all up, figure out how to get that rust off there, make a few, I got to get this screw out of here. I broke it off. I was trying to force it in there, and I just should have known that. I should have tapped this. That would have worked better. So I got to fix that, put that, mount that back in there, clean the case, tie everything up, and clean the knobs, and oops, there's my finger, how unprofessional. And I'll be about done with this thing. I went ahead and rudimentarily cleaned the cabinet, but it's got lots of years of stains on it. And I still got to do something with this blade here. Still got that little rust shining through, and I ain't figured out what to do with that yet. Might take some steel wool and a little bit of cleaner, and I don't know yet. I hadn't figured that out. Anyway, I'm done for the night. I'm going to pick up my mess, turn everything off, and go in the house. So I'll see you when I come back. Okay, that should be the last video, hooray, of this thing. This is the Rc146 Sencore Handy 75. I've completed it. As good as it's going to get. Just kind of a quick recap. I changed all the 1/2 watt, 1 watt resistors in here, and all of these things are to tolerance now. Let's see, the sand-on resistors all were good except for one section, which is right here. And I just, if you'll see that lead bent right there, I just cut that section out of the way, substituted this 25 ohm 20 watt wire round resistors, just mounted it on the chassis, so this thing will handle anything I throw at it, which I don't intend to burn stuff up like the former people did. The next thing is all the small value capacitors all check good. Even these tubular ones here, they check good, no leakage. I'm happy with it. All they're relatively accurate, so I'm good there. Then finally, these guys right here, these electrolytics here. There were 10 sections in all, 8 on these two, and then 2 on that one. And I decided to keep everything the same as factory. So I ordered 10 of new electrolytics from, let's get a little bit better light there. But that's the electrolytics, as close to the values I could get. I did notice that these here were marked 22, but they're checking 20 on my tester. They're a little bit low, which affects the overall reading, but you know what, it's close enough. Horseshoes and hand grenades, right? I just mounted it on a little perf board. I'll name them C1, 1, 2, 3, 4, C2, 1, 2, 3, 4, and then C3, 1, 2. And as I said in the previous segment, I just made a cheat sheet. I went down and mapped what connected to what, gave it IDs, gave the switch some numbers, and then transferred all this over to this chart. I was able then to make my PC board, wire up everything, and I only missed 2 connections. I had 2 blues backwards, just because I was careless, not because of my nomenclature. But that's that for right there. I've cleaned the cabinet. The cabinet was, I mean, it ain't perfect like factory. I could put a little armor all on it or something like that, but it's good enough. It was loaded in cigarette residue, cigarette smoke residue, but it's good enough for me for what I'm going to do. So let me stop a minute and I'll put it together, and then we'll look at it one more time. And finally, the finished product. It's all put back together, completed. I cleaned the knobs up the best I could. Oh, this thing had been in some harsh conditions, you guys. I'm not going to lie about it. I had little rust pits everywhere on this stainless steel, if you can see. I cleaned this up. I polished it a little bit with my Dremel polishing, but I didn't really want to get too aggressive because I really didn't want to mess with any of this artwork or writing on this thing. I've cleaned it up best I wanted to. I didn't feel like going any further. It's good. The only other issue that I might run into, and I think I'm just going to spray a little contact cleaner and a little deoxit in these connectors right here. I could have changed them all out, but quite honestly, two things stopped me from doing it. A, I'm cheap, and B, I'm lazy. You know, I think these things will be fine. I'm going to spray them with electrical cleaner, maybe a little deoxit, you know, blow them out. You know, I think they're fine. As long as you got good tight banana leads, I think this will work fine, so I'm not too worried about it. But that's it. I've tested everything. Again, I figured out that it's kind of weird. It's because if you go A here, you know, you gotta, it fooled me, you know, 2, 2, 4, 6, 10, 10, 20, 25, 40, 25, but when you get over here, then everything changed, and I thought this stuff was backwards. No, it's not, because if you follow A around the radius, A is on the outside left, but as you change past the 12 o'clock positions, now A becomes on the right side, and transitions past the 12 o'clock position, I guess you could say. So I was thinking this stuff was backwards. It's not. It's like if you look here, that says A, so this is the dividing line. This is A, that's the dividing line. So once it gets up here, A becomes, instead of being on the left, A becomes on the right. And you know, once I figured that out, oh wow, good, no problem. And recapping one more time, everything works. I cleaned all the switches, everything's clean. All the capacitors and rectifiers check good. The wire wounds are within 20% tolerance of each other. Carbon resistors are all new, all 1 or 5% resistors, so we're good there. All the electrolytics have been changed. Everything is like it was from the factory, other than the components have changed. And it's ready to go. Ready to go to work on my bench whenever I decide to find something that I need it for. But anyway, you know, a few screws here, but you know, honestly, I'm the only one that's ever going to see it. But if I ever get rid of this stuff, I'm not going to care. But you know, I could change it, but I just use what I've got on hand here. Anyway, nice little unit. Served me well. Anyway, that's that. That's that. I have it finished, completed. I'm happy with it. I've been wanting one of these for a long time, and I wound up getting two, if you remember. The other day, I got the Handy 75, but I also got this little dude right here. Little Vias, WC412A, resistance capacitance circuit box. Everything checks fine on this. All the resistors are in tolerance, capacitors are in tolerance, no leakage. Switches all been cleaned, everything's good. Case is not cracked that I could tell. So I actually got two of these dudes. So I did good in that regard. Been real fortunate. The good Lord's been fortunate to, been good to me. I need to be better for him. But it's done. I thank you guys for watching. It was fun. I don't know what I'm going to do with these. They kind of remind me of sticks of dynamite. Anybody want them, I'll send them to you. Anyway, thank y'all for watching, and please hit that like button and subscribe. And we'll talk to y'all later. I've got another project. I got two projects coming up. Boy, get too carried away. I have two projects coming up. And let me show you what one of them is. Pardon this, but this is a project that I've been working on right here. This is a Motorola R22 service communication service monitor. So I used to use one just like it when I worked for Motorola years ago. But I bought it for $800 off from a guy off eBay, and he said, "Oh yeah, it worked fine." Well, it don't work fine. The CRT's weak. Of course, I kind of figured that. I've got a workaround for that. You can just, I'll show it to you when we do the video. But the other thing is the output level when the output level, when you tried to turn the signal level up, it would go into spurious emission. I mean, bad, and it would completely destroy your modulation. Modulation wasn't accurate either compared to the receiver. So, but I did find the problem. I'm waiting on the parts. When I get the parts, I'll put this on the bench. I'll show you what it's doing. We'll pull the affected module, change the parts, take out some of the field modifications, and put it all back together and see how well it works. Hopefully it works right. And but anyway, the other thing I bought is a companion to my 400D. I've actually bought a wideband audio generator that is the same era as this, the same design principle and everything. So going to get it. They said it didn't work. Buying it non-functioning. The cord's been cut off, so I got it for a decent price off eBay. So don't know what I'm gonna run into, but unless the power transformer's bad, I should be able to fix it. And I'm going to show you what it's going to replace. It's going to actually replace the 654A test oscillator. This is a really nice oscillator. It's really cool. It works fine. But I wanted one of these older rigs like this. Anyway, it's going to come in here hopefully in the next few days, and as soon as I get to it, we'll take it apart, clean it, evaluate it, make sure the power transformer is good first off. Don't want a nasty surprise. If the power transformer is bad, then it's just a freaking boat anchor. Hopefully it ain't been robbed for tubes, and it'll be a fun project. And that's all I got for now, guys. Thanks for joining, watching with me. It's been fun. I enjoyed working on that thing. It cost me about almost $60 in parts to buy all new components, but it's worth it. This thing, it's going to be perfect from now on for a long time after I'm gone. Anyway, adios, guys. We'll see you later. Bye.